solving systems of linear equations using the substitution method. So on the last lesson, we went through a bunch of slides, started here, worked through a couple examples, went over the rules of solving linear systems, walked through a couple of examples of solving with substitution, and this is where I left you guys. If you had any questions, thank you for sending them. If not, I hope that you are understanding this, and we will continue to move on today, looking at this example. So this is kind of looking at how to solve linear systems with word problems using the substitution method. So remember, when we're solving linear systems, we're looking for the point of intersection. So where the two lines would cross. So we've looked at the graphing method, and then now we're again going to continue with substitution. Next, we'll move on to elimination. So it says Dex needs to rent a bin for removing demolition material from his home for renovations. He calls around and finds two different quotes. Throw It will rent for a $200 fee plus $1 per kilogram. We Depose will rent for $50 plus $4 per kilogram. Write a linear equation to model the cost of renting from each company. So here we've already got our let statements. So let Y represent the total cost of renting the bin, and let X represent the number of kilograms of material placed into the bin. So the best way to write these would be in slope y-intercept form. So if we've got Throw It, our equation would be y equals, because this is the total cost of renting. So this would be our rate, dollar per kilogram, and this would be our fixed cost, or our y-intercept. So we would have 1x, or just x, and then plus 200 for that first company. The second company, We Depose, we would have y equals, because that's our total cost. Our rate of change would be $4 per kilogram plus an initial fee of $50. So we've got these two equations here. So remember, when we use substitution method, we want to rearrange in terms of another variable. So the way we have it written, we have y equals, so it's a single y, and it's equal to the x value plus the fixed cost in both equations. So what we're going to do here is we're going to take what y equals here and sub it in for y down here. So we're going to take this y equals and sub it in for this y to solve. So it says solve the linear system by using substitution, and then substitute the expression for y into one of the equations, and then solve for x. So looking at this, we are going to have x plus 200 is equal to 4x plus 50. Oops. So we've taken what y literally equals in the first equation and substituted in for y in our second equation and made it equal to that right side of the equation. So we're going to rearrange and solve. So I'm going to take my 4x and bring it to the other side. So that x is already there. My 4x becomes negative because we're taking it and sending it over to the other side. And likewise, we're going to take this positive 200 and send it to this side of the equation. So I've got my 4x equals 50 minus 200. So when we solve x minus 4x, we get negative 3x is equal to negative 150. And then at this point, if you remember, we divide out negative 3 to isolate x from both sides. They cancel out. and we are left with x is equal to 50. Negative 50 divided by negative 3 is 50. So we've solved for our x. We need to solve for our y value. So we take that negative 50 and sub it back into our equation. So let's use that first equation up here. So we've got y is equal to x plus 200. So we know that our x is 50. So y equals 50 plus 200. Y is equal to 250. So when we start our therefore statement, we get our therefore point of intersection, which is x and y coordinates. And we found that that is equal to our x value here of 50 and our y value of 250. And that is a coordinate, so it all goes into a set of brackets. So looking ahead, so our point of intersection is 50 and 250. So the value of x, we said up here, was the number of kilograms, and y was the total cost. So the next slide asks, what do these values mean? So what would it represent? So we had our x value of 50, and we said that x was the number of kilograms, and our y value of 250, which is the total cost. So what this represents is when 50 kilograms is thrown away, the total cost would be 250 for both companies. So that's the point of intersection. It's when both companies throw 50 kilograms away, both companies' total cost would be $250. So this question says, solve by substitution, find the break-even point. Catherine is selling t-shirts to raise money for diabetes research. The supplier charges $210 design fee plus $3 per t-shirt. Catherine plans to sell the t-shirt for $10 each. So first thing, how many t-shirts does Catherine need to sell in order to break even? The first thing we need to do is define our variables. So let x represent the cost per t-shirt, and let y represent the total amount of money. So in order to solve by substitution, we need to come up with our equations. So the first equation would be the cost to design and get the t-shirts. So that first equation, we're going to look at the supplier charges. So let's call that supplier charges. So in terms of y equals mx plus b, we know that the total amount of money that has to be paid is equal to $3 per t-shirt plus a $210 fee for design. And then Catherine, so the selling charges, how she's going to sell her shirts, we know she's going to sell them for a total price of $10 per t-shirt with no initial value. So this equation doesn't have a constant like this equation does. So if you like to put a constant, you can put the plus 0 just to fill that b value space, or you can leave it off. So we are going to solve this by substitution. So this question is easier to isolate. We can put substitute this y value into this equation. So like we did on the last page, we're going to take this y value and substitute it here. So we've got 10x is equal to 3x plus 210. So to solve, 10x minus 3x, 10x minus 3x, because we're taking this 3 and we're going to put it to this side of the equation. It's positive on the right side, so we make it negative on the left side. And that is going to be equal to 210. 10x minus 3x is 7x equals 210. Here we divide out that 7. 7 from both sides, because what we do to one side, we do to the other. And then we've got x is equal to 30. So we have defined x as the total cost per shirt. How many t-shirts does Catherine need to sell to break even? So if we substitute, this is just asking us about the t-shirts. So we actually don't need a point of intersection here. If we're interpreting this question properly, how many t-shirts does she need to sell to break even? We are only looking for that x value, not the y value. If you did solve for the y value, the hope is that this would be the same price here. You would get the same y, so that we can see that it's breaking even. It's the same amount along the y-axis. So for this question, we're technically done. So this is asking us how many t-shirts she needs to sell to break even. She needs to sell 30 t-shirts. Catherine needs to sell 30 t-shirts to break even. And that's it. So your homework will be listed. Check the weekly schedule and spend some time with this, because this is a bigger concept. It's a little bit trickier. It's a little bit harder. So spend some time with it to make sure that you understand it.